Welcome to Plutus IAS, and today we are covering Orgel diagrams. So, Orgel diagram is used in inorganic chemistry to predict the spectral information regarding a complex, regarding how many transitions are possible in that. So, for the case of Orgel diagrams, what we need to know about? First, we need to know about that it uses term symbols for the prediction of drawing the molecular orbital diagrams for the cases out of which we can predict the number of transition taking place from one orbital to the other one. So for this case, first we need to know our D, 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 D. D, 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 and D. It should be D0, D1, D2, D3, D4, then that's D5, it should be D10 right here, this should be D6, D7, D8, D8, D9, and that should be D10. मैंने कम बना दिया, ज़्यादा बना दिया. Okay. 0, 1, 2, 3, 4, 5, 6. Right. So here, the cases what we need to do are this one. So first we have this will have the D term, this will have the D term, this will have the F term, then that's D, then that's S, then D, then F, and this will be again D. Now, for writing the term symbol, we need to know the spin multiplicity, which will be given by as 0, 1, 2, 3, 4, and from this onwards go opposite to it, which is 4, 3, 2, 1, 0. So these are the term symbols. Now, the next thing that arises is if you are having a complex, if you are having a tetrahedral complex, that means for a tetrahedral complex you can wait. So the diagram can exist for a D term as you can have two types of orbitals. For the case of tetrahedral, it will be your T1G or A1G. For this case, right, T1G. For this case, it will be, it's not should be T, sorry, it should not be T2, it should be E, it should be T2. It should be T2 and it should be E. Now, for which configurations we need to make it for octahedral complex or for the tetrahedral complex? So there is a concept called hole formalism. Hole formalism means whenever you have a configuration which requires only one or two electrons to become half filled or completely filled, like the case of D3, D4 or D8 and D9. These four configuration in which the diagram will be inverted. The tetrahedral will follow the octahedral diagram, the octahedral will follow tetrahedral diagram. So for this you can clearly see this is the case of the D splitting where the E orbitals are below and T2 are above, as in the case we know for CFT. So this diagram will be followed for tetrahedral geometries that include for the cases of D1. For your exams, you will never ever get the cases involving S. So we only need to restrict ourselves between the D and F terms. So the configuration we have are the D1, D6, D4 and cannot be 4. For D1, D6, which do not D1, D6, where there is no hole formalism, this diagram would be followed. But if you're having an octahedral geometry, then hole formalism will occur, and instead of EG orbital, which used to be CFT as your base, it will be the T2, which the T2G which used to be below, and EG which used to be in the upper state will now get inverted. So for this case it will be written as EG if you are having an octahedral complex, and T2G here if you are having for the octahedral complexes. For octahedral complexes, whole formalism that is being followed, the whole formalism is being followed for the case of D4 and for the case of D9. So whenever you encounter a configuration which involves D4 or D9, this diagram would be followed. Now, for this case, the inversions of diagram would be followed. This will be followed for your normal octahedral complex, which means that are the D1 and the D6. The D1 and D6, while for the case of tetrahedral complex, this diagram would be followed for the case of the complex which have whole formalism or of which their configuration would be inverted, and those are the ones for the D4 and D9. D4 and D9. So for the case of this, how many transitions are possible? For case of octahedral complex, one transition is possible from T to A, and the one transition is possible from this to this. So there are total of two transitions which can be defined for a D term that involves either tetrahedral or octahedral complex. Now, by a similar logic, we can also move for F orbital, F splitted term, which also includes a P term. Here it will be A to G. This is your T1G. This is your T2G. This is your A to G for F orbit for your P term. This is for your F term. A to G, or it should be no, it should be your A to G. T1G, T2G. Sorry, it will be. I've made it wrong. Sorry. It will be for the cases. It will be it will be T1G or the F orbital, then it will be T2G again for F, then it is the A1G which will be at the top, and this will be T1G for the case of P orbital. Now for this case everything will be inverted. Here the term will be T1G is below, T1GF will be here. Now, in whole formalism, these two molecular orbitals, because of similar symmetries, they repel one another, and this will become T1G of P term. For this case, it will be A1G right here and T2G, which is right here. Now, again, this is followed for what? If you are having a tetrahedral complex of configuration, what? A normal configuration will be, for the cases of tetrahedral, we can have whole for TD, and for the case of octahedral. So for the case of normal octahedral, which involves, the F term involves for your D2 and for your D7, this will be followed. For cases of tetrahedral, if you are having whole formalism, which is for your D3 and D4, not D4, D8 configuration, this will be followed. For this cases, it will be D8 and D9, which will be the case for your octahedral complex. This diagram would be followed. D8, D9. Sorry, it should be D8 and D3. It should be D8 and D3, while this one for octahedral, it will be for D2 and D7. So number of transition possible we can define based on this 1, 2, 3, and based on that if this is 1, 2 and the case of 3. So based on this we can predict the number of transition involving spectroscopic terms. So I hope this would have cleared all your doubts regarding Orgel diagrams, how to make them, how to remember them. So in case of any doubts, you can add it to the comment section and we'll get back to you. Thank you for joining us today.